Hello, everyone. Hello, audience. You can say hello on the chat. I'll be looking at the chat. So I'm gonna ask you what is the correct alternative. So if you can put the alternative on the chat, that would be better because then we can interact and make this presentation more fun. So let's go then. So before everything, you can download the code. So the link is the following: Rafael del Nero, Star Trek Java Challengers. Uh, and the code will be formatted in a way where I can fit them in the slides so that you can see the code more clearly. And don't worry, no planets were harmed in the making of this presentation. So there is a short, I'm gonna give you just a summary of what's gonna be the talk about. So as you can see, we'll be going from the JDK 6 to the JDK 17. We were talking about the queue, auto-closable, type inference, switch, sealed classes. So we're going to go through a lot of important features from Java so that you can develop better code. You can follow me on Twitter if you want. And this is this is the Java Challengers website where you can find more than 100 challenges there, and you can get better with Java, and you can get your certification more easily because those Java code puzzles, they are even more difficult than uh, the Java certification questions. So great to have you here. Let's go then. So this is just a little story. So this is the JDK solar system from 96 to 1210. Everything was fine here, but then in April of 2010, the big red giant absorbed the sun, and guess who was a big red giant? Oracle. And basically, those planets were obliterated, and now our mission here is to explore those planets from each JDK version so that we can um, save um, all the planets and Java itself. Okay, so this is the first question. So this is about the JDK 6. So as you can see, this is the concept about the DQ interface. And you can see that we are using the implementation of linked list. And we are using a couple of methods: add first, push, add last, and then we are using just some methods to show the information. So basically your goal here is to find out what is the output. Okay, so I'm gonna show you the alternatives. Okay, so most people think it's B. So let's see then. What is the correct answer? Oh, it's D. Unfortunately, yeah, it's D. But it's fine. Like I said, the goal here is not for you to get all the answers right. Your goal is to learn. So that's great that you are here in this talk. So I'm going to talk about the DQ interface. So this DQ is very important for Java because it's the best interface you can use for the data structure, stack, and queue. So what is DQ? DQ is a double linked list. And if you use implementation of linked list, you can add elements either on the at the end of this list or in the beginning of the list. So it's a powerful interface to keep in mind and to use. And as you know, stack and queue, those are very important data structures that you must know as a software engineer. So why it's D then? It's because we are removing the although element, and then it's gonna be those elements gonna be pushed forward, and the pick method will just pick the element on the top of the queue. The pop then will remove wharf, and then the pull will also remove the last element. So if you can see the little animation here, let me just let it roll so that it's easier to see. So wharf is added first, then the push, as you can see, the push will add although on the top, and then Scott will just be added the last. So, and then what's gonna happen is that um, although will be removed first, since it's on the top, then the pick will just pick the element, won't remove, won't do anything else, and the pop uh, will remove the first element again, and then the pull will just remove the last element. So those are uh, fundamental concepts from stack and queue, which I also highly recommend you to study those concepts before the Java implementation. Java is just implementing the fundamentals of stack and queue. If you understand stack and queue, then this interface is just very easy to understand because it just implements the fundamentals of those data structures. Okay, so let's go to the next challenge. Okay, so this is the JDK7, the door malfunction. So on this challenge, we are basically using the try with resources feature from Java 7. This is an important feature because it reduces a lot of the boilerplate code. So for example, if you're using the try with resources concept, you don't need to close the resource. If you're using, for example, JDBC, you can just put your JDBC implementation inside the try block, and that should be enough. You don't need to close resources manually when we are using these concepts. So that's why it's so important. So I'm just going to give you a brief here of this challenge, and then you can answer. Then you can give your best answer. So, okay, as you can see, we have the main method, and we are using the try with resources concept. And then we are invoking the open method. We have inception, a finally block. So take a look at the code and try to guess what is the output, okay? So I'm gonna show the alternatives. It's not anymore. Now you can answer to your best alternative. Okay, so I see here that most of you thinks it's B. Okay, so let's see the answer. Oh, it's C. It's C. Let me see who got it right. Okay, Alexandre got it right. Okay, nice. I see some people who got it right. So let me explain here. So firstly, the open method is the first one to be executed. And then what happens is that uh, the open method will just throw an exception. It will throw the runtime exception. And then it will just uh, invoke the close method. So notice that we are implementing the auto-closable interface here. So which means that if we use this ship door challenge inside the try block, inside here, the close method will be invoked after the open invocation, after the exception is thrown, and then this exception will be caught on the fourth step, and then the final block will be executed. So like I said, why this is important? Because it reduces a lot of the boilerplate code. And as the interface says, auto-closable will close the resource automatically. So that's why it's so important. You don't need to close your resource manually on the final block. You can reduce boilerplate code and make your code cleaner. So that's the importance of this feature. Awesome. So we are now at JDK 8. So as you can see, this challenge is regarding streams. So we are using the pick method and then the limit and then the for each method, just showing each element. So let's see the alternatives then. Okay, I like to see that we have many different answers, which means that you're gonna learn. So, and that's the intention of the Java Challenges initiative. So that's great. Okay, come on, Duke. Let's see the answer. So it's A. So why it's A? So you have to remember that streams are a functional programming concept, even though it's not fully implemented as functional programming in Java. It's still kind of. So the definition of functional programming is that the functions must be pure, which means that if you pass something to a function, if you pass a certain parameter, you're going to expect always the same output. Doesn't have any side effect. It will happen, always the same thing will happen, and there's no mutation on data. So this is, I think, one of the most important concepts with functional programming. And in Java, of course, there is mutation in our variables. So Java is not fully functional programming, but it does enough where we can get a lot of the benefits of functional programming. So as you can see, obviously we have a list with 3 elements, and so the peek method is just a method to debug your string, and we have the limit method. So remember that when you're using strings, so those the peek and the limit methods, those are intermediate operation methods, which means that they don't do anything without the terminal operation method. So if I remove the for each method, for example, nothing will happen. Why? Because strings are lazy. So strings will only do any kind of action if there is a terminal operation method. Okay. So why it's A? So you can see that first we just pick the element, we just show Kirk, and then we limit it to 2 elements. So that's the benefit of having a lazy strings, because it will only process what you programmed in the intermediate operation methods. So which means that it won't need to run through all the 3 elements. It will just process the Kirk and the Spock elements, and that's all. So that's why streams are also very performant. It's depending on, of course, depending on the amount of elements you are going through. Okay, so let me see who got the answer right. Okay, so yeah, Yaroslav said A. That's awesome. Raymond said A as well. Awesome. Rado said A. So congratulations, everyone. And for those who didn't get the correct answer, don't worry, because that's the intention here. You're learning. So that's the main goal, for you to learn. Okay. So awesome. And don't forget that at the end of this presentation, I'm going to give you a special gift. So stay until the end so that you're going to get a very special gift. Okay, so this other challenge is about also lambdas and JDK8. So on this challenge, you notice that we have a variable when we are doing something with this variable inside the lambda expression. So I'm gonna show you the alternatives. Okay, we have a couple of answers. So let's see then. Duke, come on. Let's see. Awesome. Congratulations, everyone. Most of you got it right. Yeah, you can see here. Andrew, sorry. Yeah, Yes, effectively final. Yeah, that's it. So exactly. So when you are using an external variable inside the lambda expression, so those variables, they must be final or effectively final. So what is an effectively final variable? It's a variable that is not changed. So if you have a final or an effectively final variable, you are okay to use inside lambda expression. But if you try to change this variable inside the lambda expression, you're going to have a compilation error. It's important to emphasize that if you declare a variable inside the lambda expression, you are able to do whatever you want with this variable. It's only external variables that you can't change at all. And there is a caveat on this one. For example, that if you pass an object to uh, a lambda expression, then you can change it. So that's why I told you that Java is not fully functional programming, because even still you can't change the door number, which is just a primitive variable inside a lambda expression. You can change an object. So if you, for example, create a person object with the variable name inside this class, and if you pass to this lambda expression, you're going to be able to change the name of the person object. So remember, Java is functional, but it's not fully functional. It's not fully functional programming. So keep that in mind. But it does enough to make our code much better. Okay? So that's pretty much it for this challenge. Let's go to the next one. JDK9. It's another short-term version. So JDK9. So pay attention on this slide. Notice that one module is using each other here, and we have the structure of the modules on the left. So focus on this slide for a moment, because you're going to need to remember a couple of things to solve the following challenge, okay? So I'm gonna give you some time. Okay, that should be enough. So this is a challenge. It's a challenge from JDK9. And as you can see in the module Reza, we are invoking some classes from module Vulkan. So we are also using some reflections. If you notice, we are using the getDeclared method. We are using setAccessible. We are invoking that method. So notice that we are using reflections with the other module, with the Vulkan module. Notice also that we have a private method in the attack method. So I know it's not an easy challenge, but let's try it out. I'm going to show you the alternatives. Okay, so Yaroslav answered A. Andrew also answered A. Okay, so let's see then. Mitsus C, Raymond C, 24 channel A. Okay, so let's see what is the answer. Come on, look, come on. Okay, so congratulations. who said it was C? Arten said C. Raymond said C. That's awesome. Congratulations. So one of the important concepts of modules is that we really have real encapsulation, which means that we can't break encapsulation even using reflections. And this is exactly what we are trying to do here. We are trying to break encapsulation by setting the accessible field to true. If you weren't using modules, that would be acceptable. You could do that without any problem. But when you're using modules, you have real encapsulation. So you can't do that. So obviously, yes, you can invoke the public method because like I showed in the previous slide, one module is using each other, so it's fine. It's exporting everything it needs. So you can invoke the public method. But when you try to break encapsulation, that's where the problem is. So we have the inaccessible object exception. So that's the issue here. Yeah, and as I told you, it's fine to invoke a public method because we are exporting the necessary package to RISA. But when we talk about encapsulation, we really have encapsulation with modules. And if we want to allow the other module to use those fields via reflection, we can use the opens clause, and then that would be fine. You can just open this package to the other module, and then you can break encapsulation. But you are doing that in an explicit way when you're using modules. So the benefits of modules. The first big benefit is that it's much easier now to implement new features on Java because if you notice, Java ecosystem is huge. So there are many modules. And what happened is that when Java was broken into separate modules, now it's much easier to implement a new Java feature. So that helped a lot, for example, to have this 6 months release as Java has nowadays. So now things are much faster to release new Java versions. So that was a big motivation to implement the modules feature. I think on the very top is to implement new Java features. The other thing is that you can create lightweight applications. Since you don't need to have the whole Java ecosystem on your applications, you can create much lighter application, which is good for mobile applications, for example. And you have real encapsulation. So those are the main benefits of using modules. Okay, so let's go to the next planet. JDK 10. So yeah, this is a short-term version. JDK 11 is a long-term support version, which means that the Java vendors will be supporting this version for a longer time. So with security patches and with possible bug fixes. So which means that it's kind of safer to use a long-term support version because you don't need to change very often. Okay, so we have this challenge. So this challenge is about the var concept. So it's type inference. So the name of this concept is type inference. It seems a bit complicated, and it is kind of, but so notice that firstly we have the private interface var, and it has so it's first notice that it is a functional interface. What is a functional interface? It's an interface with only one method, only one public method. So remember that, which means that we can use lambda expression if we want to. And then we are passing null to Dr. Lester var. Then we are joining some strings here. And then we are using a couple of operations with those variables. So let's see the alternatives then. Yeah, exactly, Arten. So those Java challenges questions, they're not easy and they are even more difficult than the certification questions. That's for sure. Okay, so now you can try to answer. Okay, Rado thinks it's A, Sabri thinks it's B, 24 channel A, Arten A, Raymond B, Sabri B. Okay, so let's see the answer. Come on, Duke. Awesome. So the first thing here that you can notice is that var can be also used as a name, but it's not recommended because it doesn't mean anything. Uh, so this was an initiative from the Java architects. So they decided to not create a keyword that would cause compilation errors anymore. So this means that the var keyword you can use as a variable name. It's okay. It won't cause a compilation error. And one weird thing, so this concept of var, it's type inference. It's not like JavaScript. So type inference is different. So type inference means that the variable type will be inferred and you can't change this variable type. Once you have one type to be to this var, that's it. You can't change this type. So and notice that if you want to pass null to a var, you have to cast it because, like I said, var has no type. It's just a way to infer a type. Null has no type. So if you want to pass null to a var, you have to cast it. It's kind of weird, but you need to do that. And it makes sense since it's a type inference. You need to do that. Another thing is that in Java 11 um, you can use var in a lambda expression, and yeah, you can infer a type in a method as well, and then inside this lambda expression we are just joining the strings, and then on the remove method, so be aware that we are we are using here, so the value of 1 will return the actually the new integer wrapper. So we'll not be removing the second element. Instead, we're going to be removing the third element. Why? Because the remove method is overloaded, which means that it can remove either the element by object or it can remove the element by the index. In that case, since the value of method return a new integer wrapper, we're going to be removing the third element, not the second one. Uh, it's not by index. If you were passing a primitive int type, then it would be removing the second element. But as it's not, as it's an integer wrapper, we're removing the third element. So that's pretty much it for this challenge. Let's watch the next planet. So JDK 12 is another short-term version. Okay, so let's go to JDK 13, which is another short-term version. JDK 14 now. Okay, so this concept is the switch case. So why this concept is important is because it makes the code more succinct and more concise. So instead of having the break statement, we can just have a lambda expression. So notice that we are passing enums to the get Vulkan survivors method, and we are doing a couple of operations there. And yeah, notice that we are using a lambda expression instead of using the break statement. Okay, so let's see the alternatives. Okay, we have an answer, which is C. Come on, Duke, let's see what is the answer. Okay, so it's B. So why it's B? So notice the first is that we can return a value straight away when we are using a lambda expression. And notice it's much more concise to use lambdas on this one. And so when you have multiple lines on the switch case statement, you use the keyword yield, which means that you're just returning data. So this integer we got to value off, so it's kind of tricky, this one. So this one, it's gonna return true because in the end it's gonna transform. So this comparison will be made with primitive types, so which means that they will be the same one. So it's gonna return 10. And on the second one, we are comparing a string with a new string. So what happens behind the scenes is that Java will create another object in the memory heap. So 6 won't be equals to 6 as an object. So it's going to be false. It's going to return 4. And then in the end, we are so we are just passing, we are just returning a new illegal exception, but we're not throwing it. So that's why we just print illegal exception, okay? So let's go to the next one. So this is about text blocks. So why text blocks are so important? Because again, they will make your code better. So instead of concatenating a lot of strings, you can just use triple quotes, and that will be it. You can have your strings. This is very useful in real world projects when you have a huge SQL query, for example. Okay. So yeah, we have one text block, uh, one variable without text block, and the other variable with text blocked. Okay, so let's see the alternatives. Okay, Sabri thinks it's C. And Ro is saying A, Conrad saying C. Okay, let's see the answer. Okay, awesome, congratulations. So it's C. So why it's C? Uh, so the first thing I have to remember here is that we are concatenating strings. So the method will be invoked only for the last HTML from the JDI without text block variable, which means that the formatted method won't substitute the percentage %s here, located here. So look won't be substituted in this case, but then on the JDI with text block, when we use the formatted method, then we will substitute the percentage %s with look. So when we first compare JDI dot equals JDI without text block and JDI with text block, it will be false because of the method precedence. But then when we try again and we use the formatted method again, once the string is fully concatenated, then it will work. Then it will work because then look will be substituted. And then in that case, it will be true. Okay? So let's go to the next planet. JDK 16. Record. So this is a very important concept because you can create very easily immutable objects, and record is nice because it gives you for free the equals and hash code methods, and you don't even need to declare your fields on the record. So you can just declare them on the constructor. So this is a very nice feature because it's also reduced a lot of the boilerplate code in Java. Okay, so notice that we have the commander record, we are using generics, and we have a constructor. It's kind of weird, this constructor, right? But it is a constructor. And we have the main methods using the commander record, uh, using the new ship record, and we're doing a couple of operations there, okay? So let's show the alternatives. Okay, you can try answering. Okay, Sabri says it's C. Let's see the answer then. Come on, Duke. Congratulations, Sabri. That's awesome. So, okay, first thing is that we can use generics if we want in the record, um, in a record. And you notice that we are using compact form of a canonical constructor, which means that we don't need the parentheses. We can just use like that. And we have a check there where we are checking if ship is serializable. And then notice that we are declaring a new record inside the main method. So we are declaring the new ship record. And then notice that we'll be printing Spock, which is fine. We are just passing Spock in the constructor. But then we are trying to pass new ship to a new record. But notice that this new ship record it's not serializable, which means that in our validation there, we're gonna throw runtime exception. Okay, so let's watch the next one. So this is the pattern matching feature. It's not fully completed yet, but it is very powerful because it can make your code so much better. So instead of doing those kind of crazy cast operations, you can just use pattern matching. That makes your code so much better. So notice here that we are overloading the shoot method. So we are passing here many different types to the shoot method. And okay, so let's see the alternatives. So you can start guessing what is the alternative, what is the correct answer. Okay, you can try it out. Okay, Sabri thinks D. So let's see the answer. Raymond said it's C. I can't pronounce the other name. Sorry about that. But okay, another try with C. Okay, let's see that. Okay, so it's D. So why it's D? So yeah, there's a catch here. I should have told you. So 11, it's not 11, it's 1L. So yeah, it's just so this is horrible because it's very it makes our code it makes our code not clear. So it's not a typo, it's actually an L. And what happened is that when you concatenate a string with an integer, with a long, sorry, uh, it's gonna become a string. And a string implements comparable. That is gonna fall into the comparable. When we pass true to a method that receives an object, of course it will be auto-boxed to a Boolean, and Boolean implements comparable. So it's going to fall into the comparable if statement. And on the third shoot, we are using string buffer dot toString, which means that it's also comparable. String is comparable. And then the last one is the runtime exception object, which is a serializable object. Okay, so we're gonna have false, 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 and then a runtime exception. So that's the reason. VDK 17. So do we still have time for going to this last challenge, or if we have time? Okay, time is over. Okay, so I have to rush here. So I can just explain to you why sealed classes are important. Sealed classes are important because you can make a better code design, and you can restrict inheritance. Okay, so this is what we saw here. So we saw the queue, type inference, lambdas, sealed classes, instance of. So we talked a lot about many important concepts. So who am I? I'm Rafael del Nero. I'm a Java champion, author of the Java Challengers book, Golden Lessons book, and I'm an Oracle Ace. So this is the gift I told you that I would give you. So this is the low-hanging Java Challenges book so that you can practice more. I know that this Java Challenge presentation is quite difficult and challenging, but the intention, like I said, is not for you to get all the answers right, but to have fun and learn. Okay, so I'm gonna share with you this link on YouTube so that you can get the best of the benefits, so that I can help you even more. You can download the gift here. So I'm sharing the link here. You can just use the link.
Thank you, Rafael. It was mind-blowing, and I actually enjoyed every puzzle I saw. They are really tough. So you're right. It's hard to guess, and great job.
Thank you so much, Arten. Happy to be here again and being able to help the Java community. That's always great.